This video is on topic 2.1, types of chemical bonds. Today we're going to review the different types of chemical bonds: ionic, polar covalent, nonpolar covalent, and metallic. My name is Alice Pudi, and I'm happy to be back with you on AP Daily. In a previous unit, we talked about electronegativity, which is the ability of an atom to attract electrons in a chemical bond. And we went over the trends for electronegativity based on the periodic table. So as you can see as a review, as we go from left to right on the periodic table, electronegativity increases, and going down the periodic table, it decreases. Now remember that you don't need to know specific number values for electronegativity. You don't need to know that carbon is 2.0 and nitrogen is 3.0, but you should be able to tell or know that nitrogen is more electronegative than boron, and that will be enough for what we're going to be doing. A chemical bond is the attraction between the nucleus of one atom and the electron of another. And so unlike ionization energy, where we were interested in the attraction between the nucleus and the electrons of the same atom, now we're going to be talking about the nucleus and then the bonding electrons between two atoms. And so when you think about your bonds, you want to think about electrons as kind of being on a spectrum in terms of what's happening to them. So for an ionic bond, electrons are being transferred from one atom to another, and a covalent bond means that they're being shared, and that could either be equally or unequally. Now you can use the location of the elements in the bond to help predict what type of bond they are. And so remembering that the metals are on the left side of the periodic table and your nonmetals are on the right. So if you have a combination of a metal and a nonmetal, then that may indicate that it is an ionic bond, whereas two nonmetals would indicate that it's a covalent bond. Just remember though that this is a predictive tool, it is not a rule. And so it doesn't mean that always if you take a metal and a nonmetal that you have an ionic bond. There are covalent bonds that involve the two different types of metals. The last type of bond is a metallic bond. And in this case, unlike covalent bonds where the electrons would be shared, let's say, between two atoms, in the case of a metallic bond, the electrons are actually not associated with any individual atom, but associated with all the different atoms that are involved in a metallic bond. And this phenomenon is known as delocalized bonding. If we take a look at the pictures here for nonmetals, what we have is our nucleus, which would be positively charged, and then our electrons that are then attached to this individual atom. In the case of metals, then, we have our positive cations, and we have these mobile electrons, which we'll call a sea of mobile electrons that can actually move all around the metals. And so that's what causes then the attraction between our protons and our electrons are what cause the metallic bonding. And then also the movement of the electrons is what is our sea of electrons or delocalized electrons. So bond polarity is the difference in electronegativity values of two different elements. One confusion that students often have is they think that electronegativity itself is the same as bond polarity, but it's actually the difference between them. Now, there are notations that we use when we discuss bond polarity. And so if you have an atom that has high electronegativity, we put this little symbol next to that atom. So this is a Greek letter D, it's a lowercase d, and then we put a negative symbol next to it because that indicates that that element's going to develop a negative partial charge. For atoms that have low electronegativity, we use the same symbol with a positive charge because that indicates that that particular atom's going to develop a positive partial charge instead. And then the last notation that we have is something called a dipole arrow, and this is always going to point towards the atom that is most electronegative. Next, we're going to take a look at a PhET simulation called molecular polarity, and this is an excellent resource for studying polarity of different molecules. When you go to the PhET site, this is what you'll see. We're going to take a look at two atoms. And so you can see here that I have A and B. And right now, A is kind of middle in terms of electronegativity, and B is less electronegative. And so I've turned on the dipole arrow to begin with, and notice it is pointing towards the more electronegative atom, which in this case is A. I can also turn on the partial charge. So A, because it is more electronegative, has the slightly negative partial charge, and B has the positive partial charge. I can also turn on bond character. And so you can see that this is a spectrum where we have more covalent on the left and more ionic on the right. And now, based on this combination of electronegativities, it's kind of somewhere in the middle in terms of our bond. We could also turn on electrostatic potential. And so what this shows is the positive and negative charges or partial charges within our bond. And so right now, B has the partial positive because you can see that it's blue in addition to the notation that we put. And A has a slightly negative, which is indicated by the red. We could also turn on the electron density, and you can see that A is darker gray or surrounded by darker gray, indicating it has a stronger or bigger electron density. One other thing that we could turn on here also is the electric field. And so you see here two charged plates. We have a positive and negative plate, and because B has the partial charge, positive charge, it is attracted to the negative plate. And because A has the negative partial charge, it is attracted to the positive plate. I'm going to go ahead and go back to electrostatic potential though. And then I'm going to change my electronegativities. So I'm going to go ahead and take B and I'm going to put it in the middle like A. So notice what's happened. So first of all, my bond is now more covalent because the electrons are being shared equally now. In terms of electrostatic potential, now we're in the white, meaning there isn't a partial positive or negative charges that are here on our molecule. And notice there's no dipole arrow. So again, because these two atoms have the same electronegativity, then we don't have that difference between them. Next, I'm going to go ahead and change this. So I'm going to make A more electronegative. I'm going to make B less electronegative. And so what we'll see here that's happened is now the electrostatic potential has a much darker color. So B is now more positive and A is more negative. Notice the symbols have also increased to show that. And then in terms of bond character, I have a more ionic bond here because the difference in electronegativities between these two. Now, if I were to reverse this, so A is more positive, A is less electronegative and B is more, notice what happens to my molecule, that it actually switches orientation so that now A has the positive, slightly positive charge, which makes it attracted to the negative plate, and then B is now attracted to the positive plate. This is the end of the video. Thank you for watching. Please join me for our next video where we take a look at practice questions on types of chemical bonds. This is Mrs. Pooty. Have a great day.